Our next speaker is Brandon Biggs. Here. So Brandon Biggs is both a PhD student at GeorgiaTech and an employee at Smith-Kettlewell. And I've been working with him for about 4 years.
Hello.
All right, cool, thank you. We are going to talk today about XR, and we're going to talk about XR through the non-visual senses. And James already gave me an introduction about what I do. So I'm an engineer here at the Smith-Kettlewell Eye Research Institute, a PhD student at Georgia Tech, and I'm also the CEO of a company, XR Navigation. So we'll start while they get the slides up. You don't necessarily need to be viewing the slides for this, but the question is, what is XR? And it stands for X reality, and this is the combination of augmented reality, mixed reality, and virtual reality, and it's just kind of a panacea term for all of those together. So today we're going to be going through different applications for blind people that have been developed or that are being developed in pretty much augmented reality and virtual reality. There's actually not that much mixed reality that I know of that is dedicated to blindness technology yet. And it's primarily because we don't usually have any kind of haptic experience. Like those are really hard to come by at the moment. They're super early. So I think once we get there, we'll see more mixed reality experiences, but we'll go into that. Still waiting on the slide. Sorry. Okay. All right, yeah. Cool. So there's a myth out there that virtual reality and augmented reality require vision. This is 100% wrong. And actually, blind people have been developing and using virtual reality probably more than sighted people. And this is a, so I have on this slide some statistics that since 2017, 400 million pairs of AirPods have been sold. That's just one virtual reality headset that is accessible to blind people. These are headphones that have head tracking capabilities. And my argument is that there are way more of those than head-mounted displays that are the visual experience, and only 50 million of those have been sold since 2017. So you've got an exponent, a big multiple of just one type of headphone that has been, made out into the world. And so if you build for headphones primarily, you'll get a lot larger audience. Visual is actually very minority. And so that's why I think the fixation on vision is an extremely nearsighted thing to do. All right, so the missing vision, yes. Yeah, all right, next slide. So accessibility in XR, what does this mean? So I'm going to go through a bunch of examples, but if you're building a visual interface for some reason, you can add accessibility to it if you add some simple pieces. So one of those is add like sounds to the interface. Like that's pretty useful, so that people with those 400 million headphones, one of those 400 million headphones can actually experience the interface with their tool. You can also add speech messages so that it can be the error messages or status messages or menus or whatever can be read out in text to speech. And I'm actually in the midst of writing a paper where we go through design patterns from blind VR developers, and they kind of describe how to do different types of interactions in virtual reality. And then there's another project that's in that just published a demo called Scene Weaver that does some Unity examples as well. So where the blind people are catching the sighted folks up very slowly, but it's happening. All right, the next is so what is the possibility of XR for blind people? And there is a lot. It makes the world more accessible by providing access to different types of products and services. It can bring equality to social interaction. So blind people are oftentimes have a lot of difficulties interacting with other people around them because they don't know who is in front of them when they're talking, or can't read facial expressions or any other body expressions. And virtual reality can give access to this information. So it can also make products like microwaves and appliances more easy to use. And so there's a lot of really awesome applications we're going to go into here. So we'll start with augmented reality. What is augmented reality? I have a definition here. I said next slide. Okay. And so it's basically putting some sort of virtual element into the real world. So it's augmenting the real world with some virtual aspect. So there's several different applications that have been developed next in augmented reality. One sec. Okay, no worries. Okay. All right, cool. So the first application that I want to go into are called labeling applications. And we developed one here at Smith-Kettlewell called camera input output. And basically, the idea is that you add these virtual labels to physical real world objects or any kind of surface. And you activate that by using some sort of maybe computer vision algorithm. Doesn't necessarily need to be computer vision, but that's what we use here, and can tell where the user's touching, and it'll tell you what that label is. So we've got an example here of camera input output at Smith-Kettlewell on a tactile map.
Welcome to Playhouse. Round table. Ground carousel. The ground carousel is flush to the ground and designed to be accessible to mobility devices. It's a spinning zone. Net spinner, nest spinner, ground carousel, cozy cocoon, and bench.
So the user is moving a stylus around this 3D model, and as they touch each of the objects on there, like the net spinner, nest spinner, bench, the voice is telling them what they're touching. And so it's basically a labeling system, but without the need of actual print or tactile labeling. So it's kind of virtual labeling. You could read that through a braille display too, if we set it up, but that's basically the idea. The next application is wayfinding. And there are quite a few of these applications around, and we're going to be hearing probably more about one of them, which is Clue. And what these applications do is put some kind of virtual experience around the physical space. So the user can either turn their head and hear objects that are around them, or get some kind of navigational information through the real world as they actually walk through the real world. And so they're helpful for doing indoor navigation, outdoor navigation, any kind of navigation you can think of. So those are the basic category of these navigation applications. And some examples are Clue, Good Maps Explore, and Microsoft Soundscape. Next. The next category of objects are human and object identification. And we saw some examples of how these are being developed earlier today. And it's basically, can you identify what this object is? Can you identify who this person is? And within that, there's a lot of details, like I want to be able to read what medication this is, or what type of chips are these that I'm holding up. And so there are a number of applications out there that do that, including Microsoft Seeing AI, Alexa's Show and Tell, and Orcam also does some of this as well. Next slide. There are also some games that do augmented reality. Unfortunately, there aren't a ton of them, but one of them is called Zombies Run. You can download it on the App Store, and it helps you work out. And as you're listening to these this audio game, it's audio only. You can hear zombies chasing you, and you have to run, like physically run, to get away from those zombies. And if they catch you, you die. All right, next slide. So what are some future possibilities in augmented reality? Well, of course, improving all these existing types of projects that I mentioned, they're still really early stage and there's a long way to go. So of course, improving the existing projects. There's also a need to help blind people develop these tools. So applications like Unity that are often used in VR or augmented reality applications is not accessible at all for blind people to develop with. So blind people have to develop everything from scratch at the moment, or using a lot of tools, and it's a hard high bar to build these applications. So often these apps are built by sighted people, and so we need more tools to help blind people build their own tools. Also, there is a need for inexpensive glasses that have some kind of camera so that blind people don't need to be holding their phone to do all these cool tasks. And every blind person will tell you that when they came out of the womb, they lacked extra pairs of arms that they really desperately need. So when you're having your dog guide in one hand and cane in the other hand, you don't have another hand for a phone. So you need that extra hand. And if you can put it on your nose, and that would be much, much better. It's also a lot more natural to be pointing a camera with your head than with your chest, which is what's often done. So that needs to be developed. All right, next. So we're going now to virtual reality, which is actually my favorite and what I work in. So what is virtual reality? It's a multi-sensory simulated environment. Now listen again, there is no mention of vision there explicitly. It's just one of the multi-sensory experiences. So, all right, next slide. So the first application of virtual reality are what are called cane simulators. And there are some really cool ones in development. Unfortunately, they haven't quite made it to mainstream yet. So I can't actually buy one, but they're really awesome. And I can't wait till they do come to my house. And what they are is basically some way to simulate a white cane. So the user can move their cane left and right and up and down and feel different textures and objects. And when they hit those objects, they get some kind of stimulus back. So I think the coolest one that's been developed so far is called Cane Troller. I think Microsoft built that, and it had like a break when the user would hit an object. So their hand would actually physically stop. And as you moved the cane across the ground, it had different vibrations based off the different textures. It was super cool. I didn't actually try it, but I talked to people who used it before, and that's the description they gave me. So we need more of these done, but there's a lot of research being done in this space with making virtual canes. Next. The next one are navigation simulations, and these are like intersections. So blind people have to learn how to cross really complicated intersections through sound. And sometimes if you live out in the country, you don't have complex intersections. You don't even have traffic. So you can't even, practice some of these that you might encounter in the city. Say you're going to San Francisco because you got a new job or something. So that is really important to allow blind people access to these types of simulations. And so intersections is one. There are a couple others here that allow blind people to, virtually simulate different experiences that they might get themselves into. But I think intersections is the poignant example. Next one is exhibitions, and there aren't very many of these yet, unfortunately, but this would be like putting a museum in a virtual reality experience. So rather than actually physically going to the museum, why would you do that? You can just put it into a virtual reality experience and explore it from your favorite chair at home. There's one demo that's out there called Scene Weaver, and I also mentioned this earlier because it's actually supposed to be a demo for how to make VR accessible, but they do a museum exhibition, which is pretty cool. Next. The next is actually my favorite, and it's maps. So geographic map information. And there's been several different types of research. One of them that I'm working on is called Audium, and we do it here at Smith-Kettlewell. But the idea is that you can convey spatial information such as, oh, there's a music stand here that's right next to the podium, and there are chairs and the doors on the back. So that's basically what a map can convey to a blind person without the description, and you can get the distances and spatial information. Next. The next one is socialization, and we've got a few of these. VR Bubble is telling people how far, it was a paper telling that had a VR experience that showed people how far they were away from others, and Second Life is another example. Next. All right. All right, false duck. All right, cool. The next one are games. And this is kind of where blind people have really shown that VR is super, super advanced in the non-visual community. So there are these things called audio games, which are games that are made by and for blind people that are completely using audio or sometimes tactile stimuli. And they are these multisensory simulated worlds. So I'm going to show you an example. So a lot of times people say that social interactions are really hard for blind people, even in virtual reality. They don't know how to do it. But I'm going to show you an example of VR that is non-visual that blind people built. Next. Play the demo.
Hello, this is Sam. This is just a very small demo of a few of the various nonverbal social interactions that can take place on Survive the Wild. For simple ease of coordination, I'm going to be performing most of this on my own character. However, if somebody were to be around me performing these actions, I would hear them positioned using the 3D audio system. In Survive the Wild, a character can very quickly sit or stand or clap or snap or jump or walk around. And again, if I was a listener, I would be able to hear other characters walking around positioned in 3D. Those various sounds you're hearing, like the occasional breathing sound and the chip eating sound, are just stat indicators that you can ignore. There's also several nonverbal socials you can perform in Survive the Wild. You can pull up a menu and select a social that you want to broadcast to everybody around you. For example, I can open the menu and then I can press G twice for gasp, and then I can press enter. And then everybody around me will hear that gasping sound. And there's a bunch in this menu. Like I can laugh, or I can itch, or I can rustle and stretch, or I can yawn, or various other random actions. If I pick up grass, which is a surface I'm currently standing on, players around me will be able to hear that. Or I have also just opened my inventory. I can then select this water bottle. I put it in my right hand. Now I can press a status key to hear what I have in my hands. Now, if I select my water bottle, I'll have drawn the water bottle, and I'll be able to press another status key to hear this information for a player around me. Of course, if I open the water bottle, that has a sound which, again, everybody around me can hear. And that goes for every single item on the game. Survive the Wild also has a clothing system which people can use to express themselves a little bit. I can see what I'm wearing right now. And people could hear me wearing another clothing item. For example, if I want to wear these worn down slip-on shoes, I just select it and put it in a hand. And as I wear it, you can hear it makes a sound that everybody around me would be able to hear. And of course, you can press a key to see what clothing those around you are wearing. And if I check this for somebody else, I will be able to see their gender as I'm checking their clothing. And I think in a very small nutshell, that's most of the major features that Survive the Wild has to offer in terms of nonverbal social interaction. Of course, if that doesn't cut it, you can also voice chat and text chat in various different channels. But there's several ways you can communicate nonverbally in Survive the Wild. And if a player is attentive, you can pick up quite a bit of information about what's going on.
So it's done. We've solved VR social interactions, nonverbal social interactions. So what are the next slide? What are the possibilities here that still need to be done in VR? So, yep, 1 minute, cool. We need to improve all these different projects that I mentioned. The next major innovation should come around force feedback and tactile experiences in virtual reality, and allowing blind people to build their own VR experiences. Although we do have stuff like Survive the Wild, Unity, again, which is like the hardcore VR platform, is completely inaccessible, and it needs to be made more accessible. Next. Thank you to our funders, National Institutes of Health, the National Institute on Disability, Independent Living and Rehabilitation Research. And next slide. So I wanted to put a conflict of interest statement that I am commercializing Audium, which is one of the mapping tools through my company XR Navigation. Next. Thank you. What questions do you have?
Any questions from the audience? I saw actually.
I know, so people who don't have, people with blindness used to learn Braille. I'm kind of wondering whether it's still a useful display modality that you see a future, like digital Braille displays. And I couldn't understand some of those audio streams that went by. Is like learning to interpret 4X speech a skill that is like really helpful?
Well, for Braille, it's about as useful as reading print at this point. So if you find print useful, then Braille is useful. So yes, Braille is definitely useful. And all these, the text messages that you heard could also be read through a Braille display. We just didn't talk about it because it's kind of a given for most blind people that if they hear it through a screen reader, they can also read it on a Braille display. So yes, absolutely. Braille is critical and still live and well. So there is some, tactile displays that are being developed, and even I think we'll probably hear about some later today. And so there is definitely some opportunities in those like larger full scale tactile displays for some kind of virtual reality experience, but those haven't been released yet, and so we don't really know what that would look like. But yeah, absolutely. And for the understanding the speech that fast, yeah, you definitely need to practice, but that was not too fast. Come on. That's relaxed speed. But yeah, they were saying stuff like, what the person was wearing. So kind of understood. He said it afterwards. But yeah, that's normal speed.
Hi, Bobby Bodenheimer, Vanderbilt University. Thanks for the really interesting talk. So in your wish list, as you went through your talk, I'd like to kind of divide it out into sort of two things. One are just sort of fundamental improvements in XR devices and technology, like force feedback for VR, which everybody wants, and inexpensive AR glasses, which everybody wants, and then things that are specific to the visually impaired, which would be more accessible development tools. And could you expand on the latter? I mean, I understand improved accessibility development tools, but are there other things that would be specific to the visually impaired for VR, AR, XR that that you could talk about specifically?
Putting accessibility into all the existing products, that's probably the next big thing. So assuming that the people that are using your tool will be using those really ubiquitous VR or AR headsets, the headphones, that would be probably really important for blind people. But blind people are not. It's not hard to build for them if you kind of think about a non-visual user of your tool, and so it's definitely something that a lot of people, not just blind people, could use. And so I wouldn't necessarily group that in there with stuff only for blind people, but it would help blind people if they could access this information through text or speech or some kind of a non-visual experience. But it's basically just those applications, application development tools, accessible application development tools, and then also the applications themselves being built for non-visual use.
Right, thank you.
So should I, Lucas had his hand up before you. Trying to be fair. Lucas.
Brandon, first of all, I want to appreciate your advocacy for Braille. And my question for you is, when we are using, for example, the head tracking features of AirPods or something, it's usually working better if we turn on noise canceling. And that can be very distracting if you're blind and walking around with noise canceling on. And I imagine that if you're using a VR goggle, can also be a little weird if you can't have audio feedback of your surrounds. In terms of a designer issue, have you guys thought about a way to approach that question?
Most of the stuff I do is for pre-trip planning, but I would imagine that the way that you would design something, I think Microsoft Soundscape is meant for that kind of experience. And so what they do is they allow the user to say when they want to hear the audio stimuli, or they'll just make it very short and easy to cancel. I think that would be a good way to do it. And then not doing a lot of like sounds that would be distracting in the environment. And so it needs a lot of user testing, but it's something that you can wear. It should be not used with noise canceling. That would just be a really bad thing if you're traveling with noise canceling on as a blind person. So yeah, I think it just needs to be tested and kind of experimented with. And I think Microsoft Soundscape is working on that as an example.
Yeah, I just wanted to thank you, Brandon, for a great talk. And just to follow up on 2 points. Firstly, Lucas, I think the point that you're making, the noise canceling is actually to cover a bug, which is that the latency in the tracking means that the synthesized sound and the environmental sound are always delayed with respect to each other. So that's why Microsoft's doing that, I think. And then the other thing, just to go back, Brendan, to your point, my neighbor's point here about making things accessible. If you think of one example of placing audio sources in a 3D environment, currently you have to do that visually, which seems insane. And so when you think about making things like Unity accessible, it's not just making the interface accessible, but it's actually thinking about accessible interaction design for doing the kinds of things you have to do within VR.
Yeah, and a lot of the tools like the audio maps that I've been working on allow you to do that.
Okay, I think that is all we have time for now. Thanks again to Brandon.